Okay lads, hope you're all keeping well. I said I'd do a video today just on resistor values, okay, and calculating resistors. We done this before. I think it was near the end of second year. Well, it would have been just before we finished up for the lockdown that time. I think we done these, alright. These don't come up the whole time. They come up in question 2 as part of the electricity and electronics question, alright. So we'll do half an hour on it there today. This video won't be that length. You can practice some questions on it just to re-jog your memory in case they do come up, alright. We do need to learn a lot more about different types of electronics and what to do. I'll make another video on that. So just today we'll be focusing on resistor values, alright. So a resistor is, you know what they're like? They're kind of a oblong shaped thing like so, and a wire comes out either end of them, alright. And on that resistor is different bands, okay, of different colors. And what the resistor does, it limits, alright, it limits current. And it's measured in ohms. Alright, so the purpose of a resistor, if you have a circuit or electronic component or thing like that, that will burn out, say for instance like an LED, if there's too much current ran through it, you need a resistor, okay? That limits the flow of the current and means it can work without breaking, essentially. Now, for different types of electronic components and different circuits, you need different types of resistors, alright? So the ones we use in school are fixed resistors, alright? They have a fixed value, but there's many different types of them. A higher resistant or a higher resistor value means that less current will flow, and a lower one means more current will flow through, alright? So what you get given is times in the packs you will have different types of resistors, but they don't actually stamp the value on them, okay? So you wouldn't have a resistor with 220 ohms wrote on them. You would have a resistor with different colored bands. Now, I don't know why they do that, why they just don't stamp the number on them. I do not know, but we need to be able to figure out, if you're given a resistor, what value it is, alright? So, first things first, we're going to pick a resistor. Now, I'm just going to pick one off the top of my head, okay? So I'm going to draw the value. I'm going to draw it out here, okay? So we have a resistor here, and our wire comes out each end. Now, we have our first band, our second band, our third band, and we'll go our fourth band here, all right? Now, this first band is the first number, so I'm just putting in the hash sign for a number. This band here is the second number. I should write that a bit smaller. And then this third band here is the number of zeros. Okay. And the fourth band is the one that's always at the bottom. These three are grouped close together. This one here is tolerance. Okay, so we've red, black, gold. Alright, so that's gold. First things first, the first value is red. We come up to our table, we can see that that is 2. So you can follow the table, red is 2. Then we have red again, which is another 2. Then we have black. Okay. Now, black means 0. So there's no number of zeros in this. So you just leave it as 22. Now, if I were to change that, okay, I'm going to change this now for the minute to make it a bit easier to red here. Alright, so this band is now red also. That means that it's 2 again. You do not write down 2. The third value always indicates the number of zeros. So it's 2 zeros. So 2,200 ohms. All right. Then we have a tolerance level, okay, which means it's not exactly 2,200 ohms. It will somewhere between plus or minus 5%. Why 5? Because this band is gold. We look up in the tolerance values. The tolerance values are 5%. All right. What you have to do next is get 5% of 2,200 ohms, okay? So what you do, you divide by 100, multiply by 5, which actually ends up equaling 110, okay? So, you know that either side of 2,200 ohms is the value of the resistor, right? So first things do, you take it away from 2,200, which will leave you with 2,090 to the value, okay, of 2,310 ohms. All right, that is the value of that resistor. Okay, so it's somewhere between 2090 and 2310. Okay, so what you have to look at is the first two bands are the first and second number. The third band is the number of zeros, and the fourth band then indicates the tolerance. So the value of this resistor is 2,200 plus or minus 5% tolerance, okay? That's normally all you'll ever get asked for. Then they might go one step further and say, well, work out what that tolerance value is. So you get 5% of 2,200, which is 110. You take it away from it, it's 2,090 and 2,310. I can't remember whether it's leaving cert or junior cert maths you do this in. It's what's known as a margin of error. Alright, so that's calculating resistor values. So what I'm going to do is I'll pause the video, I'm going to draw out another one, show you for practice, and then I'll give you a few to do. Okay then, so what we have here then is another resistor. The first part of the question asks you to state the resistor value, and the second part state the resistor tolerance. Alright, so this is the questions you get asked on it. So, first things first, we have to work out what value in ohms this resistor is. So I'll do it up here on the right hand side. So part 1. So the first band is green. If you look at the table, green equals 5. So that's the first digit we put down. The second is red. Okay, so we must then put down 2. And the third, the brown band, is actually 1. Now, do we put down 1 here? No. The third band always indicates the number of zeros. Alright, so just remember that. If it's black, it does not mean that there's 1 0. It means there's no zeros. Okay, that's the one where you get cut out. This third band is the number of zeros. If it's brown, it means there's 1 0. Alright, and then the tolerance then is silver, so it's 520 ohms plus or minus 10%. Alright, now that's part 1 done. Part 2 is simply then state the resistor tolerance. Okay, so we have 520 plus 10%, 520 minus 10%. Okay, now you need to work out in between that the value of the actual resistor. Okay, so 520, 10% of 520 is 52. Okay, I don't think I need to work out showing you how to do that. So the lowest value then is going to be 520 minus 52, and the highest then will be 520 plus 52. So 520 plus 52 is 572. Okay, and then the lowest then is going to be 520 minus 52, which equals 50 take away 520 is 568. Okay, So 568, or sorry, 468. My maths is bad. 468 ohms and 572 ohms. And that there is the answer to that question. Alright, so all you've done is got the resistor value, you've looked at the table, you saw the resistor tolerance then is 10%, so you get 10% of the overall resistor value. That means that the actual resistance of the resistor is somewhere in between 468 and 572. Would that be accurate? No, it wouldn't. So the lower resistance, or the lower tolerance, should I say, sorry, in a resistor means it's more accurate, okay? So you'd be wanting something closer to around 5 or 2%. Why? Because it gives you a better value to work with. So there's a big difference between 468 and 572. So the actual resistance lies somewhere in between there. It could depend, it could fluctuate up and down, alright? So that there is calculating the resistor values. So the first band is the number, second band number, third band number of zeros, and then the tolerance then is the last one. So firstly, you have to work out the actual value of the resistor, and then you work out the tolerance. Okay, so it's kind of a margin of error in it. So what I'm going to do then is, I'm going to finish up the video, I'll draw up some resistors, I'll give you the table, and I'll put it up on the Teams page then, and what you can do is you can practice some of these for homework. Alright, so if you have any questions, don't hesitate to ask. Thanks very much.